Okay, this will be part 2 of building the 6-cycle oddball. And the part we're going to start with today is this, which is the front plate on the main body of the engine. And I've already cut the piece out and I squared it. So these 3 sides are all squared and it's to the right dimension, and I put the bluing on it to save time. And so I'll just show you doing the layout. Okay, like I said, I have squared it and I'm going to do the layout now. And that's the part. It's 2 5/8 this way. I'm going to hold it up against here. And the first line I'm going to do is for the bolts that hold it together. Now I'm using cap screws on this, Allen head cap screws, and it calls for countersunk. But I happen to have the cap screws and I like working with them better. So you can do it either way. But it doesn't matter about the dimensions. It's going to be the same dimension anyway. So I'll show you the layout here. We're 5/16 of an inch up. It's 312. I'm going to put a line right across there. And then from these sides, it's a 1/4 inch there and a 1/4 inch there. So that's really easy. Set it at 250. And you can see how squaring it to dimension makes it much easier to lay it out. It's worth taking the time to get exactly dimension and square. We want 1 1/16 for that hole. It's 162. And this one here is 1 5/8. It's 1/625. And that should be the 4. Now, we got another hole at 9/16 high and 2 inches over. I'll have to go to the chart to see what 9/16 is. 562. 562 goes right here. And it goes over 2 inches. Which is right there. Okay, and then this one is 1.5 inches up. It goes right below that. Right there. And an 1/8 inch in, 125. Okay, now I'm going to locate the main hole that the cylinder goes into. So let's see what that is. That's 1 5/16 over. And it's up to 1 5/8. 1/625. Okay, now I'm going to prick punch all of those. The only thing I haven't done is the 4 holes that mount the cylinder. So the next thing I'm going to do is I'm going to draw the 2 circles on here, and they're mostly for reference. I could use the DRO to lay that out, but I want to show how to do it by hand because most of you will be doing the layout, so I'll do it that way. So the hole for the cylinder is 7/8, so 875, and so that would be, the radius would be 7/16, which is 437. So we want 437. And I'm going to set the dividers as close as I can to 437. And this is only on here for a reference. When I bore the hole, I can actually measure it, but I want to know approximately where it is. So that should be 875. And the bolt holes are on a diameter of, 1/640. So half of 1/640 is 5/820. Okay, this is a 3/4 inch radius. The top of this shows a 3/4 inch radius. I'll have to double check this. Okay, that's that. So obviously the bolt diameter, I read it wrong here. The bolt diameter is 1 and 9/30. And 9/30 is what? 281 divided by 2 equals 640. Oh, I had 740. That's the problem, I think. 640. It always pays to double check all your dimensions. If you're doing a layout like this, you can see your mistakes. And I've got one extra line on here. This is actually the act. This one is not used, this outside line. I did that by mistake. So I missed a couple of lines here. I'm going to put this line in and this line here so I can see that for reference. So this one is up, it's down 3/4, so it's up 1 1/4 inches there. You're right here. And it's a 1/2 inch wide. So that gets cut out. And you gotta get 2 inches high, which goes across here to that line, right there. Awful lot of lines. So now I'm going to put in a spotting drill and spot all those prick punch marks and drill some of the holes. Now it calls for a number 6 screw, so I got to drill the clearance hole for the number 6 screw in these 4 holes. So a number 28 drill. So the first thing I'm going to do is drill the 4 holes that mount onto the sides of the engine and counterbore them. Now this is soft aluminum, so I have to deburr each hole as I go because it leaves a little area sticking out and it won't lay it flat. So now I'm going to put a counterbore in there. If you didn't have a counterbore, you can use a drill of the proper size. It just doesn't make the bottom of the hole flat, but in this case it probably wouldn't matter a hell of a lot as long as you make sure that the screws are tight. To counterbore, you have to turn the speed way down. So in drilling this, I realized that this hole is too low, and it's my mistake. I evidently didn't have that set at 1 13/16, and I transferred from fractions to decimals and did something wrong. So I've got to move that hole up to here. So first what I'm going to do is plug this hole, and when I paint it, it won't show at all. Fortunately, it isn't in the way of anything, so I can just plug that hole with a piece of aluminum and paint over here. Is I'm going to take a piece of 3/16 aluminum and turn it so it just fits, just forces into that hole. It's going to be probably a 1/2 thousandth oversize. You just pound it in there and flush it off and forget I did it. That's going to be just about right, I think. So I'm going to take and file a little chamfer on the end of it. I'll part that off of there. I'll just finish that off with the sander later. Right now, that's the way it's going to stay. This screw head measures 140. So what I'm going to do, I'm going to bring this drill press down till it touches, lock it. Then I'm going to set my dial indicator here. Okay, I'm going to bring this down, lock it. And I'm going to set that at 0. So I'm going to go 140 deep.
And cowboy, you got to do it really slow speed. 50. 100.
140. Now we'll check the screw. Make sure it fits in there good. And it's flush. We want it probably a little bit below flush. But we're going to go another 3 or 4 thousandths. Just to have it a little below. We'll go 45. We'll go into this one. So there's those 4 holes. So now I'm going to go to the second hole. And this is just a screw hole that holds a little slider piece that goes back across. I think that's quite a bit smaller. It's a 256, 2 holes. So you have to get the tap drill for a 256. So the chart says that the tap drill for a 256 is a number 51 drill, and that's for a 60% thread, and that's what I'm going to use. Now we'll tap it. In soft aluminum like this, you have to make sure you clear the tap quite often so you don't get it clogged up. Okay, the next thing we're going to do is the center hole for the cylinder, and that's quite large. And of course I'm going to do that on the milling machine. Now I could use a center finder and get that exactly where it belongs, but in this engine you don't have to worry about it this way too much. It could be a 16th off. This way is a little critical. If you're within 20 thousandths, you're fine. And that's right on. I'm going to step up on this with a few drills, and then I'll go to the boring bar and get the exact size of the hole. Okay, now we're going to put a boring head on this instead of doing it in the lathe. You could put this in a 4-jaw, and you could center that originally with the prick punch hole and do the whole thing and then run a boring bar through it and get the exact same. This is a little more setup, but I just thought I'd show you this so you'd have an idea of how to do it. Okay, we're going to take a test cut on that. Turn this way down. Getting a nice clean cut there. The print says 875 for this hole. And right now we've got 760. So we only just got to go a little over 100 thousandths. So I'm going to take out 20 on this next cut, which is 10 thousandths on the dial. I'm going to take another cut of 20, which is actually 10 on the dial. Taking 10 off, and it equals 20 thousandths on the hole. I'm going to measure it again and see if we're on track here. Yep. 800. That's just about right because we had 60 of this, so we took 40 out. Let's go another 10, which will take out 20. $875, right? We got 840, so I can take another 20 out of there. So I'm going to try setting this at 7. That should give me 14. It should be pretty close. Now, if you should happen to go oversized, it doesn't matter. You just make the cylinder a little bigger to fit in there. See, that's 4 over. So that's no problem at all. I just make the cylinder 4 thousandths larger. And there's a nice cut. Double check my dimension, make sure I'm right. 875. We're 4 over. So we're good. We can take that out of there. As you can see, that makes a really nice bore. So now that we have all the holes in it, now I'm going to cut these features in here and do that little archway up there. And this part will be finished. The reason I keep it square to the end is because I got something to grab in the vise and so forth. You don't want to cut these features in first. Because of the boring and the chips, you can see that it took all the bluing off, so I can't see my line there. So I'm going to have to re-blue this and get that line back on there so I can cut the curve. So, because I have to redraw that line, I don't have a center point anymore. Now I could take a pair of calipers and set it the right width and just draw it around by doing that. But what I'm going to do is just make a plug that goes into here that's 7/8 with a center on it, and then I can just use the calipers again. And then I'm going to save the plug because I might have use for it some other day. I have to get that a 1/4 inch thick, approximately. Shouldn't quite fit in there yet, but now it should. Wow, just barely starts in there. It just barely fits. I'm going to take just a spring cut off of that. I'm not going to turn the thing in. I don't have to drive it in and out. I'll just part that off of there after I put a center in it. I'm going to saw that off now. I've marked it with the parting tool. So now that I've reestablished the center, I'm going to go to that 3/4 inch radius and redraw it. Okay. Now I have to put that little line there because I've got to cut in here too. But where is it? At 3/4. At 2 inches. So I'm going to use this for a reference point, and I'm going to come down 1/2 inch, and that's the thicknesses of the sides, and that should be proper, hopefully. And I'm going to just mill it out to this line. The way I'm going to zero this is I'm going to come down on this 5/1000 feeler gauge until it just drags. That's good right there. And then I'm going to zero this, come over here, and come down my 5/1000. Okay, and now all I have to do is go down 1/2 inch, and I've got my dimension. One inch 62, and I go 1/67, so I got to come 5/1000 more. That's supposed to be 1 inch 250, and it's 262. So I've got to come a little more in there. There it is. 1 inch 250. Then we're going to go for the 2 inch measurement. We come down a little bit here. Two inches exactly. Now we got to get this one to 2 inches, and I've got to probably take a cut on that and then measure it. We're only about 25 over, so I'll just put that in there, and we'll take a slight cut on it and then remeasure it. According to my caliper, it's 5 over, so I'm just going to come down about 3 on that. Pretty good. I'd say that's pretty close to 2 inches. I'm going to just take this over to the sander and just sand that round by eye. There it is. The part's finished. So that's it for this part now. I still have the 4 cylinder holes to put in there. And I noticed on this engine that I didn't do it to the plan. I did it the opposite way. I've got the bolts going in from the back and screwed into the cylinder. So in that case, I would drill this ahead of time and with a clearance hole. But I got to find out why I did this. I know it's because of the way it's assembled. It's almost impossible to put studs on here and then get a nut started on here, and it's really fiddly to put it together. If you can put the cylinder on this piece and then screw it on, it's much easier, I think. And I think that's why I did that. That's one change I did make in it. So this is going to wrap up part 2, and I'll get this whole thing figured out and why I did that. I'll probably have to take the other one apart to see how I disassembled it, because of the way the crankshaft is, I know that was one of the reasons. This crankshaft you can't take out of there once you put the engine together. And I changed that too. I've actually got a journal on here so I can remove the piston, take it apart. It's all for ease of maintenance. So there will be a few changes. Thank you very much for watching. And if you like what you saw, give me a thumbs up. Subscribe to my channel. I really appreciate it.